Hello everybody, this is Mrs. Snook with section 1.3 part A. We're going to do 1.3 over 2 days, and today we're going to focus on the continuous functions. So today we're going to find the domains and ranges of functions using vertical line tests and sort of a graphical method. We're going to determine the intervals or sections where functions are increasing or decreasing. And then we're going to define the relative maximum and the relative minimum. So maximum and minimum. Those are our key ideas for today. So let's get started. First off, finding the domain and range of a function. So look at the function on this page. And what we have here is part of a parabola where we have these filled in circles, those circles on the end there. That's where your graph stops. In your book, if it did it just like this with no arrows and no dots, that means it keeps going. But if we have little circles there, a filled circle and an open circle, that means that the graph stops. So for the domain, which is the x values, I want you to notice that the domain starts, let's get a color here, starts here and it goes all the way over to here. So here is our domain. Using the x values, it starts at -1 and stops at 4. Now the -1 is included, so I would use a square bracket. The 4 is not included, so I would use a curved bracket to write the domain. You can also write it like this: -1 less than or equal to x less than 4. All right, the range. Now that one is the y variables. So the range goes from here up to here. So there's our range, this area. Using the y's, it goes from -5 to, oh, it looks like I made a mistake here. Oh, no, I didn't. And then up to a +4. The -5 is included, the +4 isn't. So -5 up to +4, or you could say -5 less than or equal to y less than 4. All right, next one. We're now going to find just the domain of a function, and we don't have a graph this time. I have a function f has points, g and h both have equations. So remember, the domain is just your x's. So for function f, our domain is -3, -1, 0, 2, and 4. So -3, -1, 0, 2, and 4. Now for g and for h, since you're using equations, there's 2 rules you need to follow. Rule number 1 is you cannot divide by 0. And rule number 2 is you cannot do even root of a negative number. So what that means is I'm going to have to look at each of these functions, and I need to look for rule number 1, do I have a variable in the denominator anywhere? Rule number 2, do I have an even root anywhere? If the answer is yes to either of those, then those are the areas you're going to exclude. So look at g of x. I have a -3x squared plus 4x plus 5. There's no variable in the denominator, so no need to worry about dividing by 0, and there's no even roots, so there's no need to be concerned about rule number 2. That means that all real numbers are in the domain. So for this one, your domain is all real numbers. You can write like that, ARN, for all real numbers. You could use the fancy symbol for all real numbers, which is an R with an extra vertical slash in there. Or you can tell me in notation, you can say negative infinity to positive infinity. Now look at H. We are dividing by an x plus 5. I have a variable in my denominator. So rule number 1 applies. I cannot divide by 0. So therefore, x plus 5 is not allowed to equal 0. If I subtract 5 from both sides, that says x is not allowed to equal negative 5. So that's the range, the domain for this one. X cannot be negative 5. Any other value of x is fine. Now we're going to find the domain and range of this function. We have y is the square root of x minus 4. That's an even root. So the rule that applies is cannot square root a negative number. So I'm going to take this x minus 4, and I have to say that cannot be negative. So x minus 4 has to be greater than 0. It can also be equal to 0. So now I'm going to solve that inequality. I'm going to add 4 to both sides, and that says x has to be greater than or equal to 4. So my range on this one, sorry, I keep saying range, I mean domain, I apologize. The domain on this one is x is greater than or equal to 4. And you can write it like this. You can say it starts at 4 and goes to positive infinity. So either notation works. Now the range, that's where the y's are allowed to be. Remember last time I told you if you put the square root in, then you have to take plus or minus? The square root is already there. So it's only the principal root. So what that means is for the range, y has to be greater than or equal to 0. Okay, principal root only. Let's check this on your calculator. So graph this on your calculator so that you can check. Pause the video right here to graph it on your calculator, and then when you come back, you can see what my graph looked like. All right, so here is my graph, and you'll notice that the y is only positive. I'm not seeing anything below 0. Also notice right here is 4, so that graph does not exist anywhere below 4 for x. So that just confirms what we were already saying about domain and range. Example 3. So last time we were determining if things were functions, and we didn't use graphs. We did it numerically and algebraically. This time we're going to look at the graph. Take a look at the graph in A. Do you see how a vertical line intersects that graph twice? That means this one is not a function. Whereas over here, if I draw a vertical line anywhere on this graph, here, here, I'm only going to intersect the graph once. So this is a function. So use your vertical line test. You can also use your pencil. Next is the intervals or sections of the function where it's increasing or decreasing. Increasing means it's going up. Decreasing goes down. And constant is flat. And we look at this from left to right. So when I look at this graph, going from left to right, this is increasing in here. Also increasing in here. Now the question is, what about right in here? Doesn't that look like it's flat going across there? Check on your calculator and open the table on your calculator. If you check that, you will see that it's increasing in that highlighted area as well. So for our increasing on this graph, we have negative infinity to positive infinity. Decreasing, that's a never. Because if you go from left to right, always increasing. As opposed to the example here, example B, this graph is a cubic graph. And what happens in a cubic is you get this little S shape. It goes up, and then it's going to turn around and go down, then it's going to go back up. And that's anytime you have a cubic. So this graph is x to the third minus 3x, and you put that on your calculator, you will see this. Now what we're looking for is places where it goes up. Well, this graph is going up, or increasing, from negative infinity to, right here it stops increasing. It's going to turn around. So when we get to x equals -1, that's as far as that increasing function goes. Now look what happens. I'm going to change colors here to make this easier to see. So over here is where it's increasing, in this area. And then when the graph gets to here, it turns around, it decreases. So this area in here decreases. And then it turns around again, and in this area it increases. So on this graph, we actually have 3 areas. The first area is going up to -1, 2, where the graph is increasing. Now it's decreasing. It starts as decreasing at 2, and it goes all the way to -2, where it turns around, starts increasing again. Starts at, let's see, -2, and continues up to positive infinity. So that's how we're going to write it there. Now let's take a look at this graph. This one is more of what we would call piecewise, and you'll see more of that next time when we do part B of this section. So I have one part of this graph where it's increasing. This one increases. Okay, and it goes up to x is 0, y is 1. So our graph is going to be increasing, starts at -infinity, and stops when it gets to this point, 0, 1. Increasing there. Now, from here to here, it goes from 0 to 2. It's constant in there. It's flat. So I'm going to write, since I included 0 in this interval, I'm not going to include it in here. I'm going to go to 2. I'll include it there. So this one I forgot to write is increasing. Here's where it's constant. And then starting at 2 and going on to positive infinity, it's going to decrease. All right. The last thing we're going to do is we're going to look at approximating minimums and maximum. Relative minimum just means that it's in the area that you can see. There could be more minimums, but looking at just this area that we're looking at, where's the minimum? And it's right there at the vertex is your minimum. So what you're going to do is you're going to grab your handy dandy calculator, graph this on your calculator, and it's 3x squared minus 4x minus 2. So here's what my graph looks like. Now I want to know the location of that minimum, and I want it in coordinates. So I need an x and a y. So what I'm going to do is I'm going to press second, and I'm going to press this trace button. That's going to open up a calculate menu, and I want the minimum, so I'm going to arrow down to minimum. So it gives me that graph. Now what I need to do is tell it the window to look in. So we're going to do the right bound is over there, and then I'm going to arrow over until I get past that minimum. I'm going to hit enter again, and then hit enter a third time, and it tells me that my minimum is at 0.666692. And the y is negative 3.3333. So that's the coordinates of our minimum. Now we're going to do both maximums and minimums. Minimum is where it's the lowest, maximum is where it's the biggest. This picture is in your book on page 33. So pause the video and open your book to page 33 so that you can see this better. All right, so our minimum is right here. It's at the bottom. That's a minimum. And that one's a maximum. And our minimum on this graph is at, I'm going to read it from my book. It's a little bit hard for me to read it on the screen. It says 0.5773489. That's the x, and the y is negative 0.3849. So that's your minimum. Now over on my second picture, I have the same graph, but this time I'm looking at the maximum. And the coordinates there are 0.577, 0.5 I think, 7735203, and 0.38490018. So that one is your maximum. So when I ask you for the minimum and the maximum, I would like both the x and the y coordinates. That's it for today's lesson. Thank you for watching and have a great day.